Hi, I'm SHAO XIANG, a diploma student in electronic engineering from University Technical Malaysia Malacca. In this video, I'm going to present my diploma project titled Development and Performance Analysis of Mini Solar Power Charging Systems. Without further ado, let me briefly introduce my project. This project is implemented to provide a better charging systems that can replace the conventional charging systems such as power bank. Not only that the charging systems must be portable for mobility, but also have sustainability to the environment, which is producing the energy from a renewable energy source, which in this case would be the solar energy. Hence, solar cell is also chosen as the main power supply for the charging systems to replace the old way of recharging the systems that is from the power cord. A solar cell can generate voltage via photovoltaic effects that could provide power to the whole systems. Next, I will be addressing some of the problems in the current charging systems. Firstly, the power storage capacity of the charger is limited. By that, I'm referring to the batteries in the electronic devices. The situation gets worse in areas that are lack of generation of electricity, such as remote areas or during disaster. Of course, in areas that have scarcity of electricity, power generators are an option for power supply. However, they are not environmentally friendly. The gas emissions from the generator during the electric generation process will pollute the environment. Therefore, to solve the problem, the following objectives for this project are planned. Firstly, it is to develop the solar power charging systems with battery storage. And second, to evaluate the performance of the solar power charging systems in terms of the efficiency, the charging time, and the discharging time of the internal battery in response to the electrical load. Next, the scope of this project is to use solar cell or photovoltaic cell as the main source for power supply. The solar power charging system is expected to be powered using a 6-volt 1-watt solar panel. The solar panel will function as the power supply to the entire circuit with a supply current of around 167 milliamps when the solar panel is performing at its maximum level. Besides that, the charger is also expected to have an output of 5 volts, and it will have a capacity of 1500 milliamp per hour with a lipo battery. Now let's take a look at the methodology. So this is the solar panels. It is the main supply for the whole circuit. It can output up to 6 volts. So here these two are MT3608. They are the boost converter. For this one, it will boost the output from the solar and the solar panels does not output above 5 volts. For this one, it will boost the output from the batteries from 4.2 volts up to 5 volts because the module can only output up to 4.2 volts. And this one is the main module for controlling the charging process of the internal batteries. It charges the batteries based on constant current / constant voltage methods. For this one is the LiPo batteries that act as the power storage for the whole systems when it will store the charges from the solar panels when the system is not being used. Lastly, this is the USB-A female adapter that will output the whole system through here. Next, we are going to look at the analysis of the system being developed. The following table shows the behavior of solar panels towards different intensities of light. This shows that the solar panels is heavily dependent on the intensity and the nature of light falling on them to produce any kind of voltage. The voltage varies right from 0.5 volts up to 6.1 volts. Next, the result shows the efficiency of the boost converter used that is the MT3608, as there will be some power loss during the stepping up voltage process. The efficiency of MT3608 drops when the output current is around is above 750 milliamps. The analysis of the charging battery is also being analyzed. Because the cutoff voltage of the battery is around 2.7 volts, it is not recommended to discharge the battery up to the cutoff level. Hence, I only allow it to discharge up to 2.9 volts. Lastly, it is the charging of LiPo batteries with the nominal solar power output voltage of around 5.5 volts. The voltage is based on the weather condition at that day, which is sunny condition. So, what are the advantages of this project? Well, first and foremost, it will be the environmental sustainability. It is because the system is using renewable energy as its main power source. Besides that, the solar panel generates electricity without any harmful emissions. We can also see the trend of using clean energy in this day and age. Secondly, the portability is also another contribution that it could bring to the people. Conventional power bank requires a plugging system that from the power adapter. It can be considered as the traditional way to charge, and the limited capacity of the battery is also becoming a problem. So using a solar power charger is suitable in areas that are lack of electricity. Mobile applications are ensured to be stay active for the routine usage that serve many purposes, such as the IoT project and also the cell phones. After the outcome is obtained, commercializing the systems is also advantageous. It can provide the possibility of implementing solar cells into small circuitry as the power supply that can generate electricity for mobile applications and also the embedded systems. Hence, it will boost and lift the mobile application industry. Here, we can look at the bill of material of these systems, which is quite cheap compared to the existing power bank. There are many use cases for these systems. So one of them is to act as the power supply for the IoT project that that the project may locate at remote areas that cannot reach the electric grid. Next, phone users can also use it as a normal power bank that used to charge their mobile phone. Now, let's take a look at the demonstration of my project.